Hello everyone, my name is Hemu and today's our first class for Palo Alto Firewall and Panorama training. In today's class, I am going to discuss these topics. So like I will start with what is firewall, then stateful inspection, Palo Alto Firewall history, Palo Alto Firewall operating system, what are the hardware models offered by the Palo Alto Firewall, what are the VM series devices offered by the Palo Alto Firewall. I will go through with the SP3 architecture as well, then packet flow, and how we can get the initial access of your Palo Alto firewall, how we can configure the management setting in your Palo Alto firewall. So these are the topic I'm going to cover. So these 7 topics I have divided into 2 days, day 1 and day 2. Okay, so few of the things I will cover today and few of the things I will cover in your next class. Now,
Sir, next class means it's next Saturday only, right?
yes, it's next Saturday.
Okay.
Okay, so guys, let's try to understand what is firewall. So I know like many of you already aware of that, like what is firewall and all, but like because here few of the person have joined from the routing switching background as well, few are the freshers. So let me go through with that. So a firewall is a software and hardware based network security systems. Means this device called firewall, it may be a software based or it may be a hardware based. Can you guys tell me few of the name of the firewalls like a software based firewall? Like a very basic one. Everyone, like if you are using like Linux, in Linux you have aware of the IP tables. You might aware of that who has worked with the Linux, right? And like let's suppose you are in Windows, right? In Windows we have a something called Windows Defender, right? Windows Defender is a kind of software firewall. There are a couple of other antivirus softwares is also there, like from Norton, right? Quick Heal. These are also example of software based firewall. And even though like in your Windows, you can also able to control hell lot of traffic. Let me just open this firewall, firewall.cpl. This is the command. When you will type in your Windows, it will open this here. Now you can go allow app and features, change settings. So you can see here all these app I have allowed for public and private access. This is also kind of firewall. And apart from that, actually, if you will go here, from here you can also permanently set turn on or off your Windows Defender firewall basically. And there's a one more thing in advanced settings. We have these particular rules. We have a inbound rules and we have a outbound rules. See, we have a inbound rules and we have a outbound rules. So let me first tell you what is inbound and what is outbound. So let's take an example. I have a this device here. Let's take an example. This is my PC. This is PC1. This is the internet service provider. My PC has a connectivity with this internet service provider. And here I have another PC. Let's take an example or another server here. Server 1. Let's take an example. Now let's suppose this PC, he wants to send some traffic towards this server. So what he will do, that when he will basically try to send this traffic, so first he will construct the packet. And after that, that particular packet, he will basically send out through the Ethernet adapter or either the Wi-Fi adapter, right? Or basically from the NIC card. So when your traffic going out, that traffic is known as a outbound traffic. And let's suppose this server sends some type of reply towards this PC. So that reply will go inside your PC. So that type of traffic is known as inbound traffic. I hope inbound and outbound with perspective or laptop you have got, right? So now in your PC, if you want to basically control something, let's suppose in this particular PC, I want to block some of the, let's suppose like if you will see, I have blocked this HTTP rule here. This is rule created by me, means on my PC, no one able to communicate on port number 443. They cannot able to initiate a connection towards my PC because I have blocked that traffic. Even though, see right now, see, I have a block ping rule, but which is where I am allowing that particular traffic. But if I will go and if I will change the action, I can also able to disable that action, or I can basically go into properties and I can block that particular access, like block the connection. Then ping will also stop working, or like my to my PC, no one able to ping. And let's test this particular thing actually. So I have this firewall because this is an external device only. And if from this Palo Alto firewall, I will ping to my PC, which is having IP address 11. See, ping is working right now. And if I will open the command prompt here, I'll type ipconfig. So IP address of my PC is 11. And right now, see, ping is happening. See, but if I'll go here, properties, and if I will change the action and I just go and apply. Now see, ping is stopped. See, it's not happening. Now if I'll go again here and if I will go and I will change the action, because ping I generally allowed on my PC. So let me just allow the connection. Go and apply. And if I will allow that connection, ping is start working from my firewall. Firewall is external to my PC right now. So the thing is, guys, the main objective of showing this particular small test, just to let you know, like we have a software based firewall as well. Okay, so the device which is called firewall can be a software based device, and it can be also a hardware based device, like I am having here, which is your Palo Alto 440. This is a hardware based Palo Alto firewall. Or in your production environment also, you will see most of the time you are having hardware based firewalls only. There are the virtual firewall still there, like some of the organization, they used to deploy the VMs as well. Okay, so that's the different thing. Okay, so guys, a firewall is a software or a hardware based network security systems that controls incoming and outgoing network traffic. Means what firewall will do, it will basically control incoming and outgoing traffic. Means the traffic which is going out is your outgoing traffic. The traffic which is coming in is known as incoming traffic. Okay, let me do one more thing to explain the same in a proper way. Let me start one of my topology as well. So in with regards to this topology, I will try to cover. It's loading. Still starting. Yeah, I will get the access here. So your first and second class will be very light. Okay, I will not focus running very fast. I will go very slow actually. Just wanted to build some base on you. Okay, so we will use this particular laptop topology. And this one, let me just close. Okay, here also I'll get it. And I might use here itself. Okay, so guys, let's take example of this particular topology. So in this topology, I have my Palo Alto firewall. This Palo Alto firewall having a connectivity with the internet through Ethernet 1x1 link. We have a Ethernet 1x2 interface as well, which is connecting towards your inside network or towards your LAN network. LAN means your local area network. And we do have a DMZ zone as well. What is this inside, outside, and DMZ? I will cover. Don't worry. Okay. So, if I'll say here, like till this particular point, we have a control, right? Because this particular area, whatever the network devices we are having in this area, these devices controlled by us. Do you have any type of control on this external devices? No. Like, do you have access of your internet service provider routers? Guys, tell me one thing. Do you have access of ISP routers? Write on the chat, guys. No, right? We will not having, and even though they will not provide the access of their routers to you, right? So this particular area where we have our control, we can do anything. We can do the any type of network designing for sending our traffic. So if I will talk about with perspective of your entire organization, the traffic who is leaving your organization boundary or your organization edge is known as the outbound traffic. What is this traffic? This traffic is a outbound traffic. And the traffic who is coming towards your organization is known as inbound traffic. This traffic is known as inbound traffic. And this device called firewall, what it used to do? This device is a security systems. What he is doing, he is trying to control. He is trying to control the incoming and outgoing traffic. Inbound means you can think like a incoming traffic, and outbound means it is like a outgoing traffic going out from your organization. Incoming means the traffic which is come in towards your organization. And what this firewall is doing, or this device called firewall is doing, he's controlling the traffic. Now, how he will basically able to control? So, now tell me one thing. Let's take an example. We have this particular server. Let's take an example. It's a server, and this server having one public IP address 151.7. Let's suppose 100 over the internet. This server, let's suppose running the service on TCP port 443, like it's a web server. And we have this particular test PC here. From this test PC, I am going to open this server. And let's suppose this test PC IP address is 10.1.1.100. Now, this traffic will reach to your firewall. Firewall will basically inspect that traffic, or it can basically now try to control this traffic. Now, on which behalf it will try to control this traffic? Guys, any idea like how this fire will try to control the traffic? Control means it will allow the traffic, or either it will block that traffic. Allow the traffic, it will block the traffic, it will deny that traffic. So what are the parameters generally it considered here for allowing the traffic or for denying the traffic? Because if my firewall wants to control this traffic, means he needs to read the information from the packet, right? from the IP packet. What information we have in IP packet? We have IP addresses. We have a MAC addresses, right? Or majorly we have IP address and we have a port numbers. And on top of that, we have a raw data. And you might know like this OSI model or TCP IP model, right? OSI and TCP, according to OSI and TCP model, we have a layers, right? We have a layer 7, then we have a layer 4, we have a layer 3, layer 2, and layer 1. At layer 1, we have a 0 and 1s. It's a physical layer. At layer 2, we have a Ethernet header or we have a frame. Then at layer 3, we have a IP addresses. Either we have a source IP and we have a destination IP. At layer 4, we have a TCP and UDP, major protocols. And like we have a source port and destination port field. At layer 7, we have a raw data according to this TCP IP model, right? No. Now guys, see, this firewall wants to control this particular traffic. So what it will basically, if he wants to allow or deny the traffic, it needs to take the help of this particular information only, right? Because this is the information available into the packet. Now guys, tell me one thing. It's a very, very basic or a CCNA level question. From this PC to this server, and just think about we have a proper routing. From this PC to this server, what are the things are common on the packet? Let's suppose this test PC, he has created one packet with that information. On that packet, we have a source MAC, which is ABC, destination MAC address like CEF, for example. Source IP address is 10.1.1.100. Destination IP address like 150.1.7.100. Source port like 3050. And source port and destination port is like 443. And here we have some raw data. Till this area, this is known as your layer 2 header. This is your layer 3. This is your layer 4. And this is your layer 7. Now tell me one thing, when your packet is egress out through this PC and it will reach till this server, what are the things will be common in this particular packet? Write on the chat what information will be similar here. Whatever information packet content when he is leaving this PC, it is also common when it is reaching till this particular PC. So Ashok, you are right. Destination IP and port number is also common. And guys, see, do not think about here public IP and private IP. We have a full two routing. Routing is there. Routing is there. We have a end-to-end routing. No net, nothing is happening. Now think from that perspective. Means, as I have understood, you have replied like layer 3 information is similar and layer 4 information is similar and layer 7 information is common, right? Because MAC address will change. Let's suppose we have a switch here, then MAC address usually change hope by hope. So I hope guys this is clear to everyone. Layer 3, layer 4 and layer 7 information will be common in this particular PC, in this particular packet throughout the path. And I am assuming there is no device who is making any type of changes. Changes is not done by any of the devices. They are just receiving the packet. They are sending out this packet. This is what they are doing. Means no. Because this is the information which is common in your packet, right? Means my firewall, if he wants to control, means if he wants to allow the traffic, means he needs to make these decisions, right? or then deny the traffic or drop the traffic or block the traffic, means he needs to basically take the benefit of this information only. According to this information only, my firewall able to make the decision. So now if I will modify my definition of firewall little bit, like firewall is a software or a hardware based device who can allow and deny the incoming and outgoing traffic on the basis of layer 3 information, layer 4 information, and layer 7 information. Right? That particular definition is true. Now, guys, at layer 3, what are the major things we are having? So, guys, at layer 3, majority of the things which is considered is your source IP address, SIP, destination IP address, and the layer 3 protocol number. Tell me the layer 3 protocol number for OSPF. What is the layer 3 protocol number for OSPF traffic? Write on the chat. So Daniel, you have answered correctly. Arjun, you also. It works on 89. What is the layer 3 protocol number for TCP? Because our major discussion will be happening on TCP. 6. For UDP? 17. So you know, if my firewall wants to block anything, it will utilize these three information: source IP, destination IP, and layer 3 protocol number for allowing the traffic or for denying the traffic. I hope from layer 3 perspective you are fine now. I'm not going in too much depth like fragmentation and all. We will keep aside right now because just a first session. So I will go very basic. So means firewall is a device who can basically allow or deny the traffic on the basis of layer 3 information, which includes the source IP address, destination IP address, and the layer 3 protocol numbers. Right? Now, at layer 4, what we have majorly? At layer 4, majority of the transport layer protocol are TCP and UDP. And in TCP and UDP headers, we have two things. We have a source port and we have a destination port, right? Means from the layer 4 perspective, my firewall will control the traffic on the basis of source port and destination port field. Okay. Arjun, regarding the bits and all, just go through with the CCNA, okay? It's a part of CCNA classes. I will only cover whatever I required from the firewall perspective. And I got one more question regarding the zones. So zone part I will cover in your 4th class. How many zones we can create, how to create everything. Okay. Now, from the layer 4 perspective, firewall utilize the source port and destination port field for allowing the traffic and for denying the traffic. Now layer 7 we can keep aside right now. In layer 7, just a raw data. Firewall will basically check your layer 7 data, and if it will found any type of exploits, threats, malwares, then it will basically block that traffic. So that discussion we will do a lot in your content ID related sessions. Okay. Here I will just restrict my disease discussion till L3 and L4 information. Okay. So now I'll go back here. So you know, a firewall is a hardware-based and the hardware-based network security system means it is a network security device that controls, means that can allow or deny the incoming and outgoing network traffic by analyzing the data packets and determining whether they should be allowed through or not based on the rule set. So guys, you know, tell me one thing. If somebody has worked with the Cisco ASA, what is the name of that rule set? If I want to allow, I want to deny the traffic, what we have to write on is ASA firewall? We have to write the access control list, ACLs. And routers also, in Cisco routers, if you want to allow or deny the traffic, we write the ACLs. In checkpoint firewall, if you want to allow or deny the traffic, we want to write the rules. That is known as security rules. In your Palo Alto firewall, same thing is known as a security policies. So if sometime when during my discussion, if I will mention ACLs or security rules or security policies, all are common, guys. Okay, do not confuse with that. And even though you can say firewall rules, all are common. Do not confuse with that. Okay, so means we can say a firewall is a device who can allow and deny the traffic on the basis of security policies. And it will basically, we will write these security policies on the basis of layer 3 information and layer 3 information and the layer 4 information. And guys, I got very good question, like, is your Palo Alto firewall able to block the traffic on the basis of MAC address? So I'll say no. Generally, this firewall we will deploy at the layer 3 level, at the edge of the network. Okay. So it can only able to understand layer 3 header properly and layer 4 header and layer 7 header. Okay. There is a layer 2 deployment is also there, but that type of deployment is not useful because we can achieve the MAC based filtering just using the switch. Then why we will invest so much cost on the firewall, right? Firewall we will always purchase for inspecting the traffic on the basis of layer 3 and layer 4. So to on like difference between security policy versus security profile, I'll cover when I will discuss your security policies. Okay, don't worry on that. So here just ask if you have any question from the firewall perspective, you know the definition and or not. And guys, also one more thing, see, what is the default behavior of the firewall and everything I will cover. Okay, so probably these type of questions I will not take on during the session, like how default rules works, everything I'm going to cover, but when times come. Today is too early to discuss these things. Okay, so just ask the question from the current topic, guys, during the session. Otherwise, our discussion will go very here and there, and I don't want that now. Okay, so let me just cover this statement as well. So a firewall establishes a barrier between a trusted secure internal network and another network which is untrusted. What do you mean by that? What is this secure trusted network? Or what is this unsecure internal network? Or secure internal network? Or what is this untrusted network? Or what is this internet? And what firewall is doing? It is basically creating one barrier, or it is a kind of security wall. Okay, like a door in your home, or like a gate in your society where you will. Sorry for that. Just give me 1 second. So firewall is, you can consider like example in your societies. Basically, we have a security guards, right? And generally, these security guards, they will allow the legitimate peoples only, and for the unknown people, they used to block, right? They will not allow the access. Now, like what firewall is doing, it is basically creating a barrier between trusted or secure internal networks. What do you mean by the trusted network? Now let me tell you one thing. See, let's suppose this particular topology is belongs to company XYZ. There is a company called xyz.com. This is their network. They have their internal switch here, and through this switch their employees are connected. These are the employee system which are connected here. Now tell me one thing, guys. This is just a one journal question, guys. Whatever laptop you will get from your office, whatever workstation is issued to you by your office, in this office, are you able to install any type of malicious, any type of pirated softwares? No. Why you are not able to do that? You will not allowed to basically install the antivirus as well. Let's suppose your organization is using some, let's suppose they are using some type of antivirus softwares. You will not allowed to uninstall that software. Why? Because you have a very limited access. You have a very limited access. You are only allowed to install the organization allowed softwares only on that system. Even though I have seen on the office workstation, we are not allowed to install the putty software. You are not allowed to install this Chrome browser or the Firefox browser. You have to limit yourself till the Edge browser only. You are not allowed to install the Wireshark softwares, right? Because you know these softwares basically may open a some type of backdoor, or maybe they can open some type of vulnerability in your PC, and anyone can try to exploit using that vulnerability. Any attacker can exploit, and he will gain the access. Let me tell you a very common thing actually. I hope most of you have used the Office, Microsoft Office like Excel, Word, and PPT type of things, right? Are you aware about the macros there? We have one feature called macros. See, if you will enable the macros, there is a macros is there, okay? In your, in if you can check on the internet, macros for this like Excel or Word or PPT, there is a macros. If you will enable that macros, even though I can just give you one doc file, and if you will run that doc file, I will gain the access of your system. It is happening with Office 3, Office 2016, 2013. Both are vulnerable for this particular macros. Do you guys aware about the VLC player? VLC media player? If you are using old version, whatever the versions we are having around 2 years back, or VLC player, I can hack your system easily. So guys, that is the main reason organization do not allow these particular softwares to install. Otherwise, any attacker can gain the access. See, your laptop is secure in your office environment because in your office, you are sitting behind your firewall. But what about in your home? In your home, you are connecting with your Wi-Fi, right? In your home, your laptop is not secure. And anyone can gain the access. Even though that particular macros things we will do in one of our lab as well. So that time you will get the idea. I will create something. I will create one malicious payload for that, and I'll try to install that payload, and we will see how harmful. And if we have a Palo Alto, how it is basically protecting us from that particular exploitative somebody is trying to gain the unauthorized access. So you know, whatever laptop we are using, like in your LAN area, so these are your employee systems, right? These are your employee systems, and we have a full faith on your on each of these peoples, because whatever workstation they are containing, these workstation basically compliant with the organization policies. On their laptops, they have a organization approved softwares. They have a proper antivirus solutions enabled there, right? So this particular area, because this is the most secure area, because we have a full trust on each other here. Even though employees why we will not trust, but whatever the workstation they are using, that workstation has lots of limitation, very limited access. So means this area is known as most secure area from an organization perspective. And this most secure area is known as a secure internal area, or the trust zone or trust area, most trusted zone here, or the inside zone. Inside zone, when I will mention, which means I'm talking about the area where I have the computers which are configured according to our organization policies. Chances of any type of exploitation or tax is very, very minimal. So this particular zone or area is known as inside zone. Inside zone or trust zone. Because here I have the computers which is controlled by my organization. And guys, tell me one thing. Let's suppose there is a one PC here, or this attacker PC. If this attacker PC trying to access this system, is he able to do that? Is anyone able to communicate with your computer sitting in your LAN zone from outside or from the internet? No. There are two reasons. First of all, this computer has the private IP. Okay. This computer have the private IP, and this attacker PC is in internet somewhere. Even though he is not aware about that PC, how he can communicate? Even though Avjit without firewall also, he cannot able to communicate. Tell me one thing, see, he is in private network. How he can able to access this private network? Even though you have a firewall here, or like you have a router here, he cannot able to do that. There is no chance at all. There is a chance. Let's think about in different way. See, this attacker cannot able to initiate any type of traffic towards this PC. But what he can do? Let's take an example. Let's take an example. I'm going little bit beyond my discussion, guys. Now, let's suppose we have one server here over the internet having IP address 200.1.1.1. Okay. This PC have 10.1.1.100 IP address. And guys, forget about this for now a little bit. And let's suppose on this interface, I have the public IP address, which is 151.7.251 public IP address on my egress interface, Ethernet 1 by 1. And I have configured the port address translation, which is PAT. Port address translation is also configured. Now let's suppose this particular server is running on TCP port 443. Now let's say this PC is trying to access this server. So what he will do? He will try to send the traffic. Now when he will establish the connection with this PC, this server, what he will do? Now maybe he will open one. This PC will also start listening on TCP port. Let's suppose 3050 random port it will choose. And on your firewall also there is an entry, right? There is a entry, there is a mapping will be create. If traffic coming on 151.7.250 and port number is 3050, then it will forward this traffic towards this particular test PC. Now, maybe this attacker can do the IP spoofing and he can launch the attack. Because now we have opened that door. On this PC, I have started listening on this particular port number, means this port is open. And my firewall will allow that traffic. Generally, it will not happen, but it can also happen. Like there is a IP spoofing can somebody launch here. Means this hacker can present himself as he's sending this traffic through this PC. But there is a multiple mechanism are there on this particular firewall level as well to block this traffic. But forget about just a one normal legacy firewall, a very limited functional firewall functionality we are having. Then there is a high chance maybe this particular PC can hacked. Okay, because now this PC itself open the door. If he is not communicating over the internet, right? And if you have configured proper security posture over in your firewall, then no one can able to hack your systems. Okay. So guys, now, as I mentioned, because in this area, here we have your employees' computers. Okay. So this area is known as a inside zone. Inside or trusted or your LAN zone. Because from outside, if somebody wants to communicate with this area, no one can able to do that. By default, everything is blocked. If these PC wants to communicate over the internet, they can able to do that, because that's that type of configuration we used to run our firewall, right? So this particular area is known as a inside area. And what firewall is doing, it is creating a boundary between your inside zone or the trusted zone with the internet, because here we have a internet is unsecure always, because we are not sure who is sitting in internet. There is a good peoples out there and there is a bad peoples out there. We have a hackers who is also active in the internet, and there is a legitimate servers are there like Google, Facebook. All these servers is also hosted over the internet only, who is basically providing some type of services. Now tell me one thing. Let's suppose this test PC now moved from LAN area to here. He is connected with your directly with the ISP. Now tell me one thing. Do you think now this particular PC is 100% secure? He is in internet now. If he is in internet, then this hacker can do the scanning and he can basically try to see if there is any type of open doors are available or not. If there is, he will found any type of doors, then he will basically simply gain the access. So this area is known as untrusted zone. If you are over the internet, which means you are in an untrusted area. So this particular area is known as untrust or outside. Untrust zone or either the outside zone means we will not have any type of faith over the internet. If you have connected directly with the internet, then we will not trust on anybody. But at least here you can trust with your employees, right? So now I hope inside or outside or like untrust and trust, these terminology is basically, I hope you understood these terminologies now. Like if I will say inside, which means I'm talking about this area. If I'll say outside means I'm talking about the this area where where I have a direct connection with the internet. Untrust, which is outside, internet, which is outside, right? Trust means your LAN zone. I hope this inside and outside is clear, guys. Write yes in the chat if you will got it. And I'm getting Yes only. So which means we are good to go, right? Okay, cool. Now, now guys, apart from this inside and outside, now we have one more area called DMZ. DMZ or DMZ is stand for demilitarized zone. Now guys, tell me one thing. Let's suppose this particular organization belongs to company xyz.com, and this company wanted to host their file servers, their web servers, and their chat servers. Let's say these are the three servers this xyz.com is having. Now, see, xyz.com is here, right? So now what I can do, let's suppose on server one, we have hosted the website of this particular company called XYZ. Means this xyz.com main page is hosted on this, on TCP port number. I will just go with 80 for now. Generally, it's used to be in 443, but I'm going with 80. On server 2, we have hosted the file services. Let's suppose we are using FTP protocol for 5 services, and FTP works on port number 21. And on this, let's suppose we have hosted the chat services. For chat, so let's suppose we are using port number 8443. Hypothetical, I'm using these numbers. Now, guys, tell me one thing. There are the three engineers. These are the computers of these three engineers. This is engineer 1, this is engineer 2, and this is engineer 3. Now these three engineer is responsible for maintaining this web server, file server, and chat servers. If they are responsible person, what they will do now? To do any type of configuration, because to run the web services on the Linux services, they have to install the Apache web server, or either they have to install the HTTPD web services, either they have to basically install the Nginx if they want to use Nginx web servers, right? These are the three most used web servers. So they have to install these web servers on this server one. For file services, they have to install BSFTPD, which basically includes your FTP services. And for chat services, they have to install one of the chat application over there. Maybe let's say they are using Java based application. So they have installed this Java application over there, right? Now, to basically do all type of coding, to do the modification, running of these services, maintenance of these, all these application, what these engineers needs to do, how they are generally access these three servers. And these three servers, let's suppose inside one of the DC or one of your server room. So guys, it is like that, like each time that these engineers, they will visit to your server room and they will basically log in and they will do, or they will use some type of remote services to access these servers remotely, and they will make the changes. What generally happens in the production environment, guys? Tell me how people usually access these servers in the production environment. Nobody is aware of that, guys. Yes, Siv, you have answered correctly. It's SSH. So jump servers, right? So SIP generally we will not use 443. Okay. We always access these services via SHS, either RDP, but these are the Linux servers. So think about we are only accessing via SHS. Let's take an example, right? So if you will see here, these three engineers, they will basically send this traffic. They will take the SSH connection. This will go via firewall. firewall forward this connection towards these servers. That's how they will communicate. Yes or no? Right? This is how the communication will happen over SHS. Now let's take an example. You have one of the user. These are your client. Let's suppose your organization is dealing with some type of sports goods. Means let's suppose these users, clients, they want to purchase some type of goods from your website. So what they will do? They will basically also send the request. So they will send the request like this. Come to firewall. It will go to your web service. This is the flow. And this time they will access this service on TCP port 80. Yes or no? Till here, guys, you have understood, I guess. No. Now the point which which we have to focus here in this area, if you have noticed, people from my trusted area, which is inside, is also coming for some type of configuration changes. And people from internet is also coming for doing some type of business. Means this is the place, or these are the servers who is receiving the traffic from internet also, and they are also receiving traffic from your inside area. Means from inside and outside, from both the places traffic is coming. Now maybe there is a high chance this hacker can also start scanning these servers on port 80, port 21, or port 448443 for some type of vulnerabilities, some type of exploits, right? So guys, this in this area, if you will say, we are having the internet facing servers. This is your internet facing servers. These are your internet facing servers or the public facing servers, right? So that is the main reason we have here this zone called demilitarized zone. Means this is a zone which is less secure in comparison to inside. Do you think this zone is secure as your inside zone? No, because inside, from outside, no one can able to communicate. But here we have allowed that communication because we want to also do some business, right? Which means this area is this area is not secure as your inside area. But it is, do you think this area is unsecure like your outside? Because this traffic is coming through a firewall, which means we have some type of security. Means this area is more secure in comparison to the outside, and this area is less secure in comparison to the DMZ. So DMZ is a area where we have a internet facing servers. This area or this zone is less secure in comparison to the inside, but it is more secure when we will compare with regards to the outside zone. So I hope you have understood the definition of DMZ. In DMZ, we always put our internet facing servers. Now let's take in one more example. Let's try to understand one more analogy here. Let me just make little bit. Let me clear little bit this. Okay, now guys, let's try to understand one more thing here. Let's take an example. If this web server, let's say we are not having DMZ, forget about this zone. All this area is starting from here till here, it is inside. And in old days, it is like that only. We used to keep everything in your inside. Let's suppose there is some type of vulnerability we are having in this web server. And because of that vulnerability, this particular hacker, he has just gained the unauthorized access of this particular web server. Now, after gaining the access of this particular web server, there is a high chance he can also start exploiting your in these particular users, computers, or whatever the internal servers may you have. There's a high chance, right? Because now he can do the lateral movement. It is happening. And guys, this attack is known as pivoting and double pivoting. He will make a pivot connection. So to avoid such type of attacks only, basically in firewalls, we have a zone called DMZ. So this is the reason to create a zone called DMZ. Now guys, two more things I want to cover. First thing is ingress. And second thing is egress. Now let's take an example, guys. This particular test PC is trying to communicate with this server. So what he has done, he has basically sent it out this traffic like this. This traffic received on Ethernet 1x2 interface. And this traffic is going out through Ethernet 1x3 interface. This is client and this is server. Now from client to server, what is the ingress interface from firewall perspective? And what is the egress interface? Ingress interface is your Ethernet 1x2 interface, the interface where we are receiving the traffic. The interface where we receive the traffic is known as ingress interface, which is Ethernet 1x2. And the interface from which my firewall sending out this traffic is known as egress which is Ethernet 1x3. Now, let's suppose this server sent the reply. So the reply will come like that. It will received on Ethernet 1x3 interface, and it is egress out or exit out through Ethernet 1x2 interface. So for the flow which is from server to client, what is the ingress interface? Ethernet 1x3. And what is the egress interface? Ethernet 1x2. So I hope guys this ingress and egress concept is clear. What is ingress interface? What is egress interface? Let me know guys if you have not understood. Anyone have any doubt on that? I will repeat it. So this ingress and egress is clear, guys. So I'm getting yes from most of you. So I hope guys I'm considering yes and I'm going ahead. Cool guys. Thank you. Now, so guys, till here we have completed our what is firewall, which is your definition of firewall. We have completed inbound traffic, outbound traffic, ingress, egress, and we have also seen how firewall basically control the traffic, which information exactly it uses, like layer 3 From layer 3, what is the information, guys, from layer 3 firewall usually use for allowing or denying the traffic from layer 3 perspective? Source IP, destination IP, and layer 3 protocol. What is the information it will use from layer 4 perspective? Source port and destination port. Okay. So generally, guys, as you see, what firewall generally used to do, it will basically allow the good traffic and it will block the bad traffic. Bad traffic means the malicious traffic. Okay. This is what the firewall is doing. We have a couple of firewalls basically. So let me write down the top vendors here. Name of top vendors. So the very so generally, we have a majority of two type of firewalls. We have a NGFW, next generation firewalls, and we have a legacy firewalls. I will also cover that part because sometime in your interviews they may ask what is the next generation firewalls and what is the legacy firewalls. Maybe this questions you will face in your interviews. Next generation versus legacy firewalls. Yeah, two one told me like they asked you, right? But that's good then. So so you're in the next generation firewall list, we have a Palo Alto firewall. Palo Alto firewall is a next generation firewall. Then we have a FortiGate firewall. Palo Alto, FortiGate. Then we have a Checkpoint firewall. Then we have a Cisco FTD, Cisco Firepower Threat Defense. Cisco FTD, these are the four next generation firewalls. Out of these four next generation firewalls, market leader is the Palo Alto. Then the second market leader is Fortinet. Then we have a Checkpoint and FTD. In the list of legacy firewalls, so I always mention in the legacy list, which is Cisco ASA, most used firewall, guys, and most powerful firewall as well. Cisco ASA. Then we have a Juniper SRX. Then we have a Sonic Wall. Then you Stone Soft. They have a firewall from HP, Dell. Multiple firewalls are there, but all are the from the legacy background only. All are the legacy firewalls. In the legacy list, like we do have a one more firewall which is like Cyber Room. I have seen Cyber Room is also used. So in legacy list, in most of the time you will either see Cisco ASA, Juniper SRX, Sonic Wall, and Cyber Room. These are the four firewall generally you will see, but Cisco ASA is the most used firewall. Then we have a Juniper SRX from the legacy list. Now, the major difference between these next generation firewalls and legacy firewalls is that your next generation firewalls can able to allow or deny the traffic, or which means you control the traffic on the basis of layer 3 on the basis of layer 4 and on the basis of layer 7 information from your IP packet. Means source IP, destination IP, layer 3 protocol, source port, destination port, and layer 7, which is your raw data. Your legacy firewall can only able to control the traffic on the basis of layer 3 and on the basis of layer 4. They are not capable enough to read the layer 7 data. They are not designed, they are not having that type of hardware and software who can basically read and understand and make the decisions. So we have a source IP, destination IP, and layer 3 protocol numbers, source port and destination port. So this is the major difference between your legacy firewalls and your next generation firewalls. Just give me 1 second, please. Let me just see. Okay, stateful inspection I will cover in a while. What we have apart from that? Okay, then we have a firewall overview, product portfolio, and all is also there. Okay. Even though I was having the entire list here, guys. Okay. Okay. So as I have mentioned, your legacy firewalls can only able to read the layer 3 information and layer 4 information. Next generation firewall can read and can control the traffic on the basis of layer 3, layer 4, and layer 7 information. Now, because your next generation firewall can able to read the layer 7 data, because of that capability, they offers FID features. FID features means you can able to control, means you can able to allow or deny the traffic not only on the basis of layer 3 and layer 4, means source IP, destination IP, and the source port and destination port. Now you can basically control on the basis of application. Let's take an example for Facebook. Facebook have multiple sub application, like we have a Facebook chat, we have a Facebook uploading, Facebook video, Facebook audio, similar to your YouTube. We have a YouTube base. We have a YouTube upload. We have a YouTube download. Multiple sub applications are there. In Google also, right? We have a multiple Google application, right? We have a like Google Drive. Gmail is also Google Sheets, right? Multiple sub applications are there. Means now, because of this feature called App ID, let's suppose you want to allow the access of Facebook, but you want to block the Facebook chat, or you want to block the Facebook video call and audio call. This is also you can able to do. Are you able to do that part using the source IP field and destination IP field? And source port and destination means using layer 3 and layer 4. Are you able to achieve that? Tell me, guys. It is not doable. Why? Because when we will read the layer 7 content, then only we will get to know, like user is accessing the chat, or he is doing the uploading, or he is doing the video call, or he is doing the audio call. So that type of control you will get with the help of app ID feature. Because these firewalls, they will have a app engine there. Okay. So this is the one benefit of this next generation firewall. The second benefit of these next generation firewall is the antivirus protection. Guys, when you will access any type of website, and if some type of malicious or some type of malicious code is coming, then it will basically come as a layer 7 data only. Guys, tell me one thing. Can we will put a malicious code into your IP header? Can we put a malicious header into your TCP header? Are we able to add any malicious code into these headers? It will not having that particular. We cannot able to add these headers because header has some specific format, right? And if somebody is violating, if let's suppose, and instead of some fixed header field, somebody has put something else. Means like your IP header coming with some data or TCP header coming with some data. Let's say somebody has added some data into option field. Then such type of traffic firewall usually block it. It will not allow that traffic because when your packet moved from one location to another location, one router to another router, or one router to another firewall, there is a parsing happens, like a layer 2 parsing, layer 3 parsing, and that parsing happens on the basis of headers only. And if we have basically put something into these headers, then the parsing will fail. Means your parsing will fail. There is some error checks used to be done at your English stage or at the very first stage. So that parsing will fail, and basically it will restrict, it will block that particular traffic. Okay. Now, because this malicious code or virus is also coming as a layer 7 only. So your next generation firewall will have a antivirus feature. They used to decode the protocols and they will to scan for viruses. If there is any malicious code, they will block that traffic right away. You will get the spyware protection. Let's suppose you are accessing one website, and in this website, it is basically sending lots of ads. Lots of ads is coming. It is also some type of spyware only, adware, which is also kind of spyware. So you will get the spyware protection as well. How exactly this spyware works, we will see in your content ID class. URL filtering. Guys, tell me one thing. Let's suppose I'm accessing one website like called www.xyz.com. www.xyz.com. When I will access this website like that, is this particular domain name, is there anywhere in your layer 3 or layer 4 information? No, we are not having that domain name. This is also part of layer 7 only. Domain name generally you will see when we will access in your HTTP header, right? We have a domain name field. Into that field only they will have a domain name. At layer 3, what we have a destination IP. And instead of www.xyz.com, we have the IP address of this xyz.com. So, to do the URL filtering feature as well, we need to read the layer 7 content. So your next generation firewall will support this also. You will get the vulnerability protection because most of the malicious code we will basically, or most of the exploit we will send via layer 7 only. Okay. So we will get the vulnerability protection. Wildfire means we will basically get the protection from unknown malwares. Okay. Data protection you will get. Let's say somebody is trying to upload the personal information or the credit card details or the Aadhaar card details, PAN card details, right? Such type of traffic also we will able to block. We will get the file policies here. Let's suppose we want to restrict the uploading and downloading of these files. All these are the features of your layer 7, and all this particular thing we will get, all these features we will get in next generation firewalls only. I have seen one question like, if let's suppose you have a legacy firewall and but you still need a layer 7 features. So what do you have to do? We have a legacy firewall. Let's take an example, Cisco ASA. Then what you can do, you can basically purchase one IPS device as well. So when you will purchase IPS device, you will get the antivirus protection, anti-spyware protection, and vulnerability protection. After that, you can purchase one more box like WSA from Cisco point of view. You will get the URL filtering here. You can purchase one more feature called AMP, Advanced Malware Protection. When you will purchase this AMP box, you will get the data filtering feature, you will get the wild file type of features, and you will get the file protection feature. So these are the 4 devices you have to purchase if you will go with the legacy deployment. Ashok, I don't know how BepSense works, so you can better check in the internet like these features are there or not. Okay. Now, I have seen one more question regarding the WEF feature. So guys who don't know what is WEF, basically WEF is a web application firewall, and generally this WEF works mostly for the at the header level, like HTTP header level. See, these particular Palo Alto firewalls can read the core information of your HTTP header. But by using WEF, if somebody is trying to do the tampering of your HTTP header parameters, they have just launched the cross-site scripting attack, or somebody has put some malicious string on this HTTP header. Because there are lots of malicious code. Even though I know, let's say if your website is running on PHP and all, I can basically just put these malicious strings over there. And when I will load this website with these particular malicious code, I will basically able to gain the access. I will get the access of that particular device as a www data user. Because all these attacks I have launched, so I know I will get the web cell access. So you know this web is a dedicated device for protecting from the cross-site scripting attack, like as on the basis of HTTP header, on the basis of SQL and all, right? So you know web functionality is not there on the firewall. Just remember. Even though you know I know this website, and I think I do have an extension as well. Not here, sorry. I have on my Kali Linux to basically I can launch these attacks easily to gain the access. There are lots of web cells are there, right? Via HTTP, you can basically import this web cell into the user's computer, right? And that particular small code of that web cell start running on that user's computer or that server, and you will get the web access. So means you will send all type of commands through the web browser itself. There's a hell lot of attacks actually. So for if you want a protection from that, then you have to go for the web solution. The web solution you will most of the time you will see in the e-commercial applications, because e-commercial application have that type of data which you wants to protect. Okay. Now guys, let me just start the stateful inspection. So before explaining this stateful inspection, I'll go here and just give me 1 second. I have to clear this diagram. Whiteboard sometime become very slow actually. Guys, meanwhile, somebody write on the chat, like let's suppose, what are the features we can configure in a router? Apart from routing protocols, what are the things we can also do in the router? Firewall diagram I will create again and I will use for router related functionality. This one only. And I have to change my board. I think I will start using some different board from going forward. That's the problem. It is very slow sometime, whiteboard. Okay. This is router. Let me duplicate it again. This is server. Okay. So this is the setup right now I was having. Let's take an example. So in this example, if you will see basically, we have a PC1 10.1.1.100. Then we have a switch. We have a router here. Then we have an internet service provider, means this router has an internet connectivity, and in internet we have a one of the server which is running service on TC port 80. And then let's suppose in this server we have a one file of 2 GB. Okay, and that particular file I want to download from this particular server. This 2 GB file I want to download from this particular server. Now, so guys, see this particular server hosting his service on TC port 80. So, this PC, when he will send a first packet, your first packet is a TCP SYN packet. In case of TCP, always the first packet is your TCP SYN packet, guys. Yes or no? Now, when this particular router receive this particular packet on Ethernet 1 by to interface, what will happen? So guys, what this router will do, this router will basically, if you will configure all the features on this router, then router will send this packet through 27 checks. I will not write all the checks. Name of few checks, right? It will go through with the ingress stage processing. It will basically go through with the header checks, header parsing. Then if you have configured the access control list, then ACLs. If you have configured the net, then it is going to go through the net. If you will configure the routing will be there, right? So now your routing table. In routers, you have a sep table as well, sep table, right? If you have configured the VPN related stuff, then IPsec, etc, right? These are the 27 checks. This particular router will send this particular packet. And after processing this packet will go out. Yeah, QS will be there. Multiple things are there. Okay, I'm not writing QS this there, PVR is there, multiple things are there. Okay, now TCP send reach to this server. Now this server is sending the reply. He will send the reply. This reply is TCP SYN plus ACK. Yes or no? Now this TCP SYN plus ACK will also go through with this all these checks: ingress, header parsing, ACLs, net, route table, sep table, IPsec, quality of service, right? And this particular traffic reached to this PC. Now this PC again send the third packet, which is known as TCP acknowledgement. TCP received by the router. Router will go through with all these 27 checks. So I'm just putting here, it will also go through the 27 checks. This packet will also go through with the 27 checks. It will forward this packet till here. Now TCP three-way handshake is established, completed, right? TCP connection is in established state. Now they will basically send the HTTP GET request. This HTTP GET packet will also go through with the 27 checks. Now from the server, we will get the response. HTTP response. Response will also go through all these 27 checks. Then they will again do some type, they will send some type of HTTP packets, post and all, right? He will get the reply because now they have to download this file, right? So let's suppose to download this 2 GB of file from this particular server 100, this PC and this server, they have exchanged total of 200 packets. Let's take an example. They have exchanged 200 packets with each other. And let's suppose this router takes around 2 seconds to process this packet. He has need 2 seconds to process another packet, means he is taking 2 seconds for processing each and every packet. Okay. So total time which is taking by this router to process these packets is around 400 seconds. I'm taking these hypothetical numbers, guys. Okay. In actual, it's not true. Router is, we have a very powerful router nowadays. Okay. But I'm going with a hypothetical number here. Now, tell me one thing. When it has done this particular checks, right? This router, the major time which is taking by this router while processing this packet, which is your net. Let me write down here your net, your ACLs, your routing tables. These are the three processes who is taking more time. Let's suppose out of 2 seconds, these processes took around 1 second to do the processing of this particular packet entirely. Means out of 27 checks, around 1 second is taken by these three services: net, ACL, and route table. And another 1 second is taken by remaining 24 services. Okay. Now, guys, so this is how device usually process the packets. This is what processing was happening before 1993. In 1993, this was the packet processing. Means this router will basically send each and every packet, either request, reply, whatever, each and every packet through all the checks. And the major checks was net, ACL, and route tables. So guys, in 1993, they have think some type of optimization. And on that optimization, what they have done basically, they have removed these major checks. Means only the first packet out of these 200 packets will go through these checks, and after the remaining packets, they will bypass these checks. They will bypass these particular checks. Only first packet will go through with all the 27 checks, and remaining packet, remaining 199 packet, for them these checks like routing engine, net engine, and ACL engine will be bypassed. They have come up with this particular approach, right? And now track to track this particular packet is belongs to, let's suppose we are getting some type of reply or some type of request. How we will basically make sure this reply or this request belongs to this flow only? So what they have done, they have introduced the session ID, session table. They have comes up with one of the technology called session table. Session table, or in clear word I can say flow table or connection table. All are similar. Session table, flow table, or connection table. And on this particular table, what they have done, they have basically stored the source IP address, destination IP address, layer 3 protocol number from the layer 3 packet, from the layer 3 header, and from layer 4 header, they have basically stored source port and destination port. Because this particular information is similar on all these packets. This information is similar on all the packets, all these 200 packets. And that particular optimization or that mechanism of the optimization is known as a stateful inspection, which is introduced in 1993 by the vendor called Checkpoint. First time. And right now, all the firewalls, they are the stateful firewall. Means this particular mechanism is implemented into all the firewalls like Palo Alto, Checkpoint, Cisco. Cisco ASA introduced this particular feature in 1994. Palo Alto, they have basically comes up in 2005 only, right? So that time they have introduced this particular feature on that firewall. In router, is still router will not support this stateful inspection, but firewall supports that stateful inspection. Just remember what firewall supports the stateful inspection. Now, because guys, for 199 packets, we are bypassing all these three checks, and we know these three checks takes around 1 second. It takes around 1 second, right? And after implementing this particular feature, how many second my device needs to process these 200 packets? Total time taken by is 201 second. Previously, it was 400 seconds. See the difference now. See the difference now. It's almost double. So guys, because of this technique, hypothetically, we have increased the throughput or the processing time of the packets in a device just twice. So I hope you got the reason behind this particular stateful inspection technology. Now let's try to understand same behavior with regards to the Palo Alto firewall, guys. Okay, now let's take an example, guys. We have a PC here. PC1. IP address is 10.1.1.100. I have a firewall here. Interface is Ethernet 1/2. This is a part of inside zone. I have one more interface here, Ethernet, let's say 1/3. This interface is a part of DMZ zone. In DMZ, I have one of the server, like server 01. Let's say this server having IP address 10.2.2.101, and this server is running his service on TCP port 22 on SHS. Firewall IP address on this interface is 10.2.2.250, and on this interface is 10.1.1.250. Okay, this is what I'm having right now. Let me go with the one transparent line here. Okay, let me also make this thing. Let me use this color for the replies. Sin plus egg, then egg, http get. Then let me go here. Let me put this thing here. Make some spaces between them. So I can write the proper information. Okay, cool. Now, so guys, here if you will see, now this PC again, he has sent the first packet. Now this is my Palo Alto firewall. Okay, I'm going with the Palo Alto discussion only now, which is TCP SYN packet. Now, this firewall basically received this TCP SYN packet, and it has basically did some processing on that packet. And what he has done, this SYN packet will go through some of the processing. Let me write down what are the things, what are the checks done by this firewall. First checks is ingress stage. Second one is flow lookup. Then I am putting the silo path. It is also known as session setup. Then your first path. Then your forwarding. Okay, now we will basically put, just guys put full your attention here. Okay, let me change the color little bit. Let me use this color here. Okay, so you know now. Now when this TCP is received by my firewall on Ethernet 1x2 interface, so what he has done the processing at ingress stage, then flow lookup, silo path, fast path, and forwarding. Means 1, 2, 3, 4, and 5. These are the main 5 states it has gone through. TCP SYN packet. Okay. I will not go explain like what exactly happens in ingress stage, but I'll just give you the glimpse of it. Okay. Just give you the glimpse of it today because this is a part of your packet flow. So I will cover in depth in your packet flow. But here I will just give you the little bit idea about that. So in ingress stage, when your firewall receives a packet, it will go through with the layer 2, layer 3, and layer 4 information. It will extract that information. Your parsing will happen. Okay. Your fragmentation reassembly will happen. And the major stuff is done in your ingress stage to get the source zone. So we know we have received this packet on Ethernet 1x2 interface. So source zone become our inside. And as I mentioned, will extract layer 2, layer 3, and layer 4 information, right? So from layer 3 header, it will get the source IP address 10.1.1.100, destination IP address 10.2.2.101, and the layer 3 protocol. What is the layer 3 protocol number, guys, for TCP? 6. From layer 4, we will get the source port and destination port field. Source port 3050 and destination port is 80. Destination port is 22 according to our communication. We will get that detail. Okay. Like this ingress checks, all these things will happen. DOS block day. What is that one? We will discuss in your flow logic class. Now, after getting this information, what it will do the flow lookup. Means it will check the session table. Is there any type of existing session is there in the session table or not? We know it's a TCP SYN, which means it's a very first packet in our communication. So we will not found anything into the session table. Means if there is no details in the session table, then it will go towards the silo path. It will go towards the silo path. Okay. Now in silo path, guys, if you will see here, if you will notice, we have a major checks. Your routing lookup is a part of silo path. Your net lookup is a part of your silo path. Your security policy is a part of silo path, which is your ACLs. And these are the main checks, main time consuming checks in your silo path. Okay, just remember this. See, silo path is very big till here. How it happens, we will cover. Even though in demo I have discussed that, but I will cover this in your next lecture, how this flow logic works. Then slow path, it will go into your fast path. After installing the session into the session table, it will go into the fast path. Okay, and guys, I have not introduced here app ID and content ID right now in this packet because TCP SYN will not go through with the app ID and content ID because it is not having any type of layer 7 data. Directly, it will go into the egress processing or forwarding stage. Okay. So this is how your TCP SYN is processed by the Palo Alto firewall. What he has done, he has now installed the session into the session table. Into the session table, he has installed the session table because firewall is a stateful device. It will store the source IP, source port, destination IP, destination port, layer 3 protocol number, and source zone. These 6 tuple information it will store. It will store that 6 tuple information. In the session table, for client to server, because in our communication, this is a client and this is a server, right? Client to server. It will store source IP address 10.1.1.100, destination IP address 10.2.2.101. Source ports, let's suppose firewall pick a random port number 3050. Destination port is always fixed, guys, 22. Layer 3 protocol number is 6. And source zone, what is the source zone? Inside. So it has this information for client to server. Apart from this information, it will also store one more information for server to client as well. And this information it will get from the first packet only. For client to server, we know, see, when we have received this TCP SYN packet on this firewall, no, I will get the reply from server 1, right? So IP address is 10.2.2.101. Means this destination IP become the source IP for server to client flow. Destination IP is, so whatever the source IP we are having in client to server flow become the destination IP, which is 10.1.1.100. 1.1.100. Now, source port. This server will reply using port number 22. Means whatever the port we are having into destination field, it will just swipe it. That become source port, and whatever we have in the source, it become the destination port, which is 3050. Okay. Layer 3 protocol number remains same for TCP, which is 6. And now source zone. We know this when this server will send this traffic, it will receive on the Ethernet 1 by 3, which is a part of DMZ zone. So this become the DMZ. Now you may ask one question, how we will get? We have to forward this packet through Ethernet 1 by 3 interface. How guys we will get to know? We have to forward this traffic through Ethernet 1 by 3 interface. How this firewall knows that? It will check the routing table. Simple. Routing table is a part of flow lookup. Yes or no? Sorry, routing table is a part of silo path. We have seen that. How this firewall gets to know? We have to allow or we have to deny the traffic. It will go through with the security checks, right? Security policy check. Security policy saying allow because we have allow rule. So he will allow the traffic. If your silo path routing, so through routing, he will get the source zone, source interface. He will get Ethernet 1 by 3 and Ethernet 1 by 3 is a part of DMZ zone. So he will get this zone. Now we have this information on the session table. And let's suppose session ID associated with this particular session is 100. This is the session ID. I will go through with the session ID as well. Okay, don't worry. How it happens, everything I will cover. But for now, just think like that. So session ID for this client to server and server to client flow is 100. There's only single session ID for both the flows. We have two flows, server to client and client to server. Now, guys, as I have said, let's suppose they have exchanged between this PC and this server, they have exchanged 200 packets. Here also they have exchanged 200 packets, hypothetically. And let's suppose this first packet took around 2 seconds for processing. Okay. Now, with the reply, this server will give the reply. In reply, we have a second packet, TCP, SYN plus ACK. This is the second packet. Now let's try to understand how this TCP SYN plus ACK is processed by the firewall. Let me. Oh, I'm not getting options to duplicate. Okay, I think I have to select here text. No, I'm not getting it. Okay, here I will get duplicate. This one I have to delete it. Now this is how your packet will be processed. TCP SYN plus ACK. Meaning of ACK shy is acknowledgement. Okay, so you know now TCP SYN will go through with the ingress stage. Flow lookup, when it will do the flow lookup means when it will do the lookup into the session table. Guys, when we will get this packet, when this packet received by the firewall, when it will do the session lookup, you know this particular flow will match. And if session is matching, what will do? It will bypass the slow path according to your stateful inspection. It will bypass the slow path or connection setup stage. It is bypassing this particular slow path, and this is how it will process the packet. Now, now third packet, TCP acknowledgement. We'll also go through with the ingress stage flow lookup. When this file will do the flow lookup, this particular flow will match, right? Because it's the same packet, right? Your source is similar, destination is similar, source port is similar, destination port is similar, layer 3 protocol is similar, inside zone is similar, right? So this will match. Guys, are you able to grab the things till here? Write yes in the chat if you are. It's a very basic, but it's good if you have that in knowledge, it's good for you. Okay. So this packet will also bypassed past path. So it is also bypassing your silo path. Okay. Now it's a TCP 22, right? So now at the fourth one, fourth packet, what you have? You have now some SHS rated packets or some SHS B2 related packet. Now guys, tell me one thing. When you have a SHS version 2 packets here, or SHS packets, is this SHS packet having any type of layer 7 data? Yes or no? Tell me. Write on the chat. Why guys you are writing no? In SHS we are not having. SHS belongs to which layer? SHS protocol belongs to which layer? SHS is a layer 4 protocol. It's a layer 7 protocol. See, this, if you will check this particular Wireshark here, we have a TCP SYN plus ACK and ACK. After that, we have a SHS version 2 packets. So if you will check this TCP SYN packet, we have only till TCP header here. We have a CIPv4 header. Then we have a TCP. These are the Wireshark captures only. See here, we have only IPv4 header. Then we have TCP header. Do you see any type of layer 7 here? No. No layer 7 in your TCP SYN. Same with SYN plus ACK and ACK. Let's try to see that. Let me click on acknowledgement. Acknowledgement packet is also similar. Then again into the SYN plus ACK, then ACK. No. But if I will click on next packet, which is this SSH version 2, we have this layer 7 data. See, this is your layer 4, but this is your layer 7 data. We have this layer 7, right? Now all the packet they are having layer 7. See, now we have a layer 7. If you want to see, I think I can do that or no. Let me just see. No, I will not able to do that. Otherwise, I should have followed the TCP stream and I can show you. But I do one thing. Let me just see if I have any captures from previously. It will be on one of my folder. Let me open Palo Alto T-shoot. And here, do I have any Wireshark captures? IGB2 I was having. IPsec Wireshark I'm having. Global Protect I was having. Yeah, Global Protect. Okay. Let me open this Global Protect. See, we have here also. Do you think we have a TCP? Okay, it is starting with fin and all. TCP SYN plus ACK and acknowledgement, right? You can see they are not having any type layer 7 data. You can go here in SYN packet and you can follow the TCP stream. See, this is the layer 7 data. But you know that layer 7 data, if you will click on this one, let's suppose I will select this part. See, it is coming from this packet onwards. Okay. So generally your SYN plus ACK and ACK, they are not having anything. In case of SSL, when you will see this client hello, now you have some layer 7 here, some layer 7 data. Okay. I was talking about this layer 7 data only. So you know now. Now let me come back here again. So now your SHS protocol have this layer 7 data. Now if it is having some layer 7 data, then it will go through these checks now. Now it will go through your app engine for app ID, related task, and it will go for content ID as well, content identification. Then your forwarding stage. So I'll come back here. Now how the processing will change a bit here. So let me go. If I can able to do the duplicate of it. I can able to do duplicate it. Now ingress stage flow lookup fast path, and after fast path it will go for app identification, and it will go for the content identification, content ID, then it will go for the forwarding stage. Now your remaining packet will go like that. Okay, now it will go like that. For now, it will go like that only, but there is a some tweak as well. There is some offloading also happens from the content engine. See, this content ID, it will go if you will configure the layer 7 protection. If your if application is already identified, then further packet it will not send through the app engine. Just remember, okay? If I have identification is done, because if you will see here, so it will clear when we will discuss the packet flow. If you will read this information here, this line, let me just increase a bit. See, app identification, if app is identifying session, if yes, then it is going for CTD. If no, then only it is going for app ID. But application is already identified, then I will not send every packet each time through the app engine, because I will do some optimization. Okay, but I'm putting these states for now, but later we will change a bit. Okay, now your fifth packet is also SHS related only. I will put SHS related only now, everything. Your sixth packet is also SHS related only. So now this is how your packet processing is happening. Now guys, if you have noticed, only your first packet is going through the slow path. And in slow path, we have a major checks, which is your route lookup, routing table, or fib table is also known as PVF table, PVF rules. This is the first thing. Second thing, your net policy lookup is also a part of silo path only. And third thing, your security policy is a part of silo path only. So means we are bypassing these particular checks for subsequent request and reply packet. See, your subsequent request and reply packet is not going through silo path. Why they are not going? Because we are maintaining the state of the session. We are maintaining state of the session. Here we are writing everything. We have written all the information for these flows. Whatever reply we will see from the server, whatever the request we will see from this client, right? For each request and reply, they are maintaining, they will process, they will basically match our session table. And it is happening because of stateful inspection feature of your Palo Alto firewall. Because of which feature? It is happening because of the stateful inspection feature of your Palo Alto firewall. Now, so guys, now in this scenario, if you will see, like for first packet, it will take 2 seconds, and for the remaining packet, it will just take 1 second. Remember one thing, guys, now. When your app engine and content engine will come in a picture, maybe instead of taking 1 second, it may take 1.2 second. Because app engine will take some time, your content engine will take some time, right? Guys, I hope you will got my point here. Shiv, just wait for user ID related lecture. I'll cover that time, not now. Now I just focus on this particular thing actually. Okay. How user ID works, we will discuss everything in detail. Even though in packet flow, I will cover when user identification happens, when user based policy is enforced by the PAN OS, everything will be covered. Okay. Now, so, there might be some extra time firewall needs when your packet go for the layer 7 processing. But let me tell you one thing. In your Palo Alto firewall, they have introduced a dedicated hardware component for doing the layer 7 checks. That was my reason to build this particular diagram. In this diagram, you can see we have this particular chip, signature match processor. It's a C100 chip. This is also known as FPGA, Field Programmable Gateway Array, or ASIC. This is a dedicated component inside your Palo Alto hardware devices who will basically do the app ID related task and the content ID related task. Means your Octeon chip, which is a main data plane CPU or the main processing unit of your firewall, this unit will not need to waste the resources for layer 7 inspection. Layer 7 task is done by the separate chip because of its architecture. Okay, just remember. So guys, I hope you got the main point with regards to the stateful inspection. The main agenda or the main summary of stateful inspection, like because of this mechanism of this technology, firewall maintain the state of a connection. And it will store that information in a table called stateful table. It will maintain that connection details into the state table or the session table or the flow table. And what it will do, for subsequent subsequent reply and request packets, it will basically do the fast pathing. It will bypass the slow path. It will bypass the slow path, and each and every packet will just take the fast path. Okay. So that is your stateful inspection, guys. Now, so now let me tell you like what they have written. So according to your TCP and IP or OSI model, at a layer 3, we have a 3-component source IP, destination IP, and layer 3 protocol number. And at layer 4, we have a source port field and we have a destination port field, right? So what generally used to done by the fire device who support the stateful inspection, it will check the layer 3 and layer 4 information within an IP packet and store that information in a separate table referred to as a state table or a connection table or a session table. All traffic flows through the firewall will be compared or inspected against the state table entries. It maintains the state of the connection when packet is traveling for the appliance, means it is maintaining the state of the connection. A stateful firewall maintain the state of the connection in the state table of the firewall. After adding information in the state table, it forwards the packet to the destination, means it will do the fast pathing. When it receives the reply packet, it matches the packet information to the state table. If firewall receive the reply packet, if match, the packet is accepted, otherwise it will drop. Means if match is happening, then it will do the fast pathing. Okay. It will do the fast pathing. Like that, it will store the information. Stateless, like your Cisco routers, they are the stateless devices. Stateless firewall watch network traffic and restrict or block the packet based on source IP, destination, source destination or layer 3 protocol. Stateless firewall do not maintain the state of the connection or session. Extended ACLs on Cisco routers is the example of a stateless firewall. Your firewall like Palo Alto, your Palo Alto firewall, Cisco firewall, Checkpoint, they are the stateful firewall. Just remember. Now, guys, let me go little bit more on it basically. So, this stateful inspection, this feature called stateful inspection, it is created in 1993 by a checkpoint engineer named is Nirzuk. So he is the person who has basically developed or invented this stateful inspection technology in 1993, and he was a part of checkpoint that time. Before checkpoint, he was a part of NetScreen, which is nowadays Juniper. So he worked for Juniper. Then from Juniper, he moved to Checkpoint. Then he left the Checkpoint and he has started his own company called Palo Alto Networks. Okay, so he is a like you can say founding member of Palo Alto Networks. So this is a little bit history about Palo Alto firewall. So what he has done, he has introduced first time Palo Alto firewalls in 2002. But that time no one considered this Palo Alto firewall. So what he has done, he has basically worked very hard and just in 3 years of time, again he has comes up with new features, new modification. And in 2005, first time he has introduced the Palo Alto firewall officially. And when he had launched this firewall, Palo Alto is the first firewall who has a support of app identification. App ID feature will be first time introduced in Palo Alto firewall. And because of this feature app based rules, because in old days, let's suppose if I want to block the Facebook traffic, then what I used to do, I used to get the entire list of IP address which is using by Facebook and I used to block. the traffic. If Facebook had changed their IP address, or if they have changed their port numbers, then we have to again request these IP address and port numbers, and we have to add them in our access control list. That was the problem most of the vendors were facing. Most of the organizations were facing because of this app ID feature. And also Palo Alto is the firewall who has a built-in feature for IPS. Means your antivirus, anti-spyware and vulnerability feature is also built in with that box. So that box become very popular, and in 2008, according to the Gartner report, Palo Alto was become the market leader in firewall industry. And since 2008 till today, Palo Alto firewall is the market leader. He is leading the market. He is leading the firewall industry. Okay. So this is a little bit history about Palo Alto networks. So as I have mentioned, Palo Alto was the first firewall who comes up a very nice feature set like app identification, identify the application. We can able to configure the app based rules, right? Because there was a major problem to block YouTube, Skype traffic, like torrent traffic, your evasive application like torrent we have, right? Skype we have, right? These traffic we are not able to block that time, but because of that feature, we can able to control them. Then user identification, user ID feature will be there. We can able to configure the user based policies on that firewall. Content identification is also one more very good feature on Palo Alto firewall. And its architecture, obviously. Palo Alto support SP3 architecture, which I'm going to cover in some time. And according to Gartner, Palo Alto is the market leader. You can see it is in a leader quadrant. Let me give you some basic idea of the Palo Alto product portfolio. So you know Palo Alto majorly working into three domains right now. They have a strata product portfolio. They have a Prisma product portfolio, and they have a core text product portfolio. This strata main business towards the hybrid data centers, internet perimeter, branch in mobiles, 5G and IoT, and endpoint. So these are the five domains where they are providing the solution. So guys, whatever we are learning in this batch, like your Palo Alto firewalls, your Panorama, it's a part of Strata product line, which will basically provide the security at your data centers, at your perimeter firewalls, in your HQ sites, in your branches, for mobile users and all. They will basically secure the enterprise networks. Then we have a Prisma solution, which is further divided into two parts: Prisma Access and Prisma SD-WAN. And their main business or their main objective to launch this Prisma solution to product to basically protect your SaaS application and your public cloud applications. Whatever application we are hosting on public cloud like Azure, AWS, whatever the SaaS application we are using right now, right? Like we are using Office 365, which is a SaaS application from Microsoft. We can use Google Workspace, which is a SaaS solution from the Google. So they will secure the cloud by using the Prisma solution, Prisma Access and Prisma SD-WAN. Then they have a log solution as well, or your endpoint solution as well using the code text. They will secure the feature. So these are the three main product line. It's the same thing whatever I have covered. So that's the main business of Palo Alto right now. Now guys, let me give you 1 minute. Just give me 1 second, please. So we are here now. Let me cover this part. After that, we will take a break, and I will, and after that, we will cover SP3, and we will wind up for today. Okay, now. So guys, if you want to understand the Palo Alto firewall, so before understanding the Palo Alto, let me just give you some brief idea about Palo Alto operating system. Okay, so PAN OS stand for Palo Alto Networks Operating System. So how they have basically built this particular PAN OS, what they have done, they basically took the kernel of Linux. What they have done, they basically took the Linux kernel here. And what they have done, they have took this Linux kernel, and on top of this Linux kernel, they have basically implemented the PAN application. The actual Palo Alto code, PAN application, means backend of your Palo Alto firewall is the Linux based only. Backend of your Palo Alto firewall is the Linux based, and front end is your PAN application. So initially, like they have used BSD Linux. Right now they are using CentOS. These are the open source Linux box. What they have done, they have take these Linux boxes. They did the customization on it. They have removed the services. They have added the services according to their requirement. And after that, they have added, after customization, they have added the PAN code, Palo Alto, I can say source code of the operating system. And whatever they have get, that is known as PAN OS. Latest version of Palo Alto operating system is 11.2.x. This is the latest version. But as per the most preferred release as per today, which is your 11.1.4 H4. I think now I have heard the name. We have a H7 as well. So I have not exactly, even though my firewall is also running the same version. Let me just log in and show you. Admin, admin add 123. So guys, my voice is coming properly. Just confirm in the chat. Azim, I think you have to check your internet, man. I have a very good internet here. Okay. There is no lag. Are you able to see any lag on my screen or writing? So guys, Azim, you have to check because most of them, they are not facing any issues. So you have to check your internet connection. I think you are not having good internet connection, I guess. So, as per in my firewall, I was running on 11.1.4 H4. Okay. I will upgrade if we will get any latest version on that same series. That's not a problem. Okay. So we will do our training into up to date version. Yeah, to one we can able to upgrade from 9.x to 11. We can able to do that, but you have to check your hardware because nowadays I have seen there's a lots of hardware devices who is not supporting 11 series. Okay, there are lots of hardware of Palo Alto who is not supporting 11 series code. This is what we have to consider. And even though I know this Palo Alto 5445, on this you have to run 11.1.x. You are not allowed to run any below versions. In Palo Alto 54, 10, 20, 30, you can able to run 10.2.x and above. So there are these are the things, and you have to always refer the documentation, because this information always you will found up to date in the Palo Alto documentation. I will cover that one. Okay, when I will discuss the licensing and all, that time I will cover. Now, so Palo Alto have three type of hardware devices, or generally Palo Alto have a hardware devices and the virtual devices. So in hardware series, these are the physical appliances. In virtual series, basically they have two flavors: virtual appliance and CN series appliance. So means Palo Alto firewall offers three type of appliances. They will offer three type of appliances. Physical platforms. So in your physical appliances, basically, let me write down these series here so you will get some idea. In the hardware series, basically, I will start like that. So we have a three categories here. We have a small size, then we have a medium size, then we have a enterprise size, or the large size devices. Okay, now I got one question like, what is the stable version of Palo Alto? Stable version is 11.1.4 H4. I have already said that in some time back. Now, in a small size, basically boxes, we are having PA 200 series. That was the series we were having previously. Okay. Now this 200 series is end of sale. Still you will get from some of the vendors, but according to Palo Alto, this series is end of sale. In this series, they are having two boxes: Palo Alto 220 and 220R. 220R they have developed for the places where humidity is there, right? So for humid location, they have to recommend go with 220R, because his architecture, his hardware design like that. Now, this in its place of 200, basically they have comes up with a new series of Palo Alto 400 series box. PA 400 series box. Okay. Now, in medium size, they are having two series, basically PA 800 series and PA 3200 series. Guys, just remember one thing, I'm not going with Palo Alto 2000 series. Will be there previously, Palo Alto 3000 series will be there, but these are the first generation boxes, very old boxes. First gen, then this PA 220, 800 and 3200, these are the second generation boxes. Or whatever I have written here, like this box, these box, they are the second generation 5200 series, 3200 series, second generation boxes. And this PA 400 is the third generation boxes. PA 400. Now what they have done, and instead of PA 800, they have introduced PA 1400 series, and for PA 3200 series, they have introduced PA 3400 series. These are the latest version, which is your third generation hardware appliances. In enterprise, they have a first generation box, which is PA 5000 series. Then they have launched the second generation boxes, which is Palo Alto 5200 series. Now, third generation boxes is Palo Alto 5400 series. At enterprise level, they also have a PA 7000 series. Like these are the 7000 7,000 series boxes, you will see in very big data centers these devices. These are the hardware chassis based devices, very powerful device. Okay, and most of the time at enterprise level you will see now 5400 and 5200. Most of the places they are having 54 and 5200 series boxes. In medium size organization you will see 800. In HQ side you will see 3200 series, and in the latest version for the new deployment 14 and 3400. And in a small size 200 or either 400 box. Okay, so these are the hardware appliances which is offered by the Palo Alto firewall right now. Okay, I will come back on them again, don't worry. Apart from these hardware appliances, Palo Alto also offers virtual appliances. These virtual appliances, you will get the OVA file, you will get the QCOW2 file, and you can basically run this virtual appliances into multiple virtual environments. Like you can run on VMware environment, right, over ESXi, ESXi. You can run on public cloud like Azure, Google Cloud, GCP, AWS, Oracle, Alibaba. You can run these particular virtual appliances into all these particular cloud environment as well. You can run this QCOW2 images into KVM environment, OpenStack environment. Okay, so they have offered these virtual appliances as well. In virtual appliances, you will see these are the series which is offered by them. We have a VM50, which is for lab environment. Then we have a VM100, VM300, VM500, and VM700. These are the VM series offered by the Palo Alto firewall. You can see VM700 can give you a throughput of 16 Gbps with app ID enabled. With threat prevention, throughput is 8 Gbps. This is the session. These are the capacity of these boxes. This is the dedicated memory, which is RAM. Okay. So these are the VM series devices. Nowadays, if you will deploy Palo Alto VMs on AWS, on Azure, and on GCP, there also you will able to see you can deploy on the basis of virtual CPUs and virtual RAM. Okay, so just when you will deploy, just read the AWS documentation if you are deploying on AWS environment. Okay, it depends on the virtual CPU and virtual RAM. If you will give more CPU and more RAM, your device throughput is more. If you will get less RAM and less CPU, then your device throughput is very less. Okay, now we do have a this CN series devices. So guys, I hope, I'm not sure, have you have worked with the micro segmentation and all, or you have heard about the Kubernetes, Docker? This is a new next generation virtualization technology, guys. If you are not having that idea, I will request within 2 years of time, just upgrade yourself towards the Docker and Kubernetes. These skill set is must now. So what you can do nowadays, you can basically run different type of applications over the Kubernetes and Dockers. And this is how the deployment is happening. When you will deploy any devices over the anything over the cloud environment or over the virtual environment, we will run Docker and Kubernetes, and on top of that only we will run our VMs, our application as a VMs. And if you want to basically protect the communication, like one VM wants to communicate with another VM through your Docker environment or through your Kubernetes environment. If you want to restrict that type of communication, then you have to go with the CN series devices like container native series firewalls. CN series device provide visibility and security to the container- containerized application workloads. Means the application who is running over the container environments like Docker and Kubernetes. Natively integrates into Kubernetes clusters. Provide layer 7 visibility, application level segmentation, DNS security, and advanced threat protection. Protects traffic across trusted zones in public cloud and the data center environment. So I hope you got the idea here. What is the CN series devices? These are the container native series firewalls. Sometimes you will also see the same series as like SFCN, secure firewall, container native. Multiple names are there because see they like right now we are not having any standard, I can say, for all of that. That's why, because I have worked with these environments actually, this Kubernetes and also I know how these environment works and all. Because still people are working on all of that. Even though your all your Prisma Access solution and all, in future you will see they will run over the Kubernetes clusters only. They are creating nowadays orchestrators to maintain everything. Even though Cisco has already created CDO, Cisco Defense Orchestrator, which you can use for control everything. Even the Palo Alto is also working on that one. Now, in after few years, you will not see Panorama. You will just see one cloud-based orchestrator from you can able to manage all your firewalls, all your Prisma solution, everything. I think from Palo it is known as SCM. Not exactly. I am not able to recall properly. But I think it is SCM. Have anyone has worked with this environment, guys? This SCM. Anyone is managing this Prisma using SCM? Yeah, Strata Cloud Manager. Yeah, it's SCM only. Yes, yes. Yeah, Kalai, you are right. It is Strata Cloud Manager, SCM. Okay. It's a upcoming technology. It will take around 3, 4 years or 5 years of time to comes and implement everywhere. But that's the future. Okay. So I think physical appliance, virtual appliance, and CN series appliance we have discussed. Now let me also give you one link here. Palo Alto firewall models. Even the Palo Alto have done lots of changes with regards to their documentation as well. There's one more link I know for Palo Guard something. Yeah, this is the one. So you can see here you will get the hardware series, supported versions. So this is the place where you can check which version is supported. Like in Palo Alto 220 box, you can run PanOS 9, PanOS 10.1, 10.2. This 11 is not supported in your 200 series box. PA4 10, you cannot able to run 9.1. You have to run these 10.1.2 onwards. Always check here. Then we have in 400 series, we have 410, 410R, 410R 5G. This is for 5G networks. Then 415 5G, 415, and we have 445 firewalls. Then we have 440, 450, and 460. Then 450R, 450R 5G, 455. So multiple sub versions are there into that series. You can check. You will get the idea here, right? Then they were having 800 series. You will not allow to run 10.2.x on this 800 series boxes, and then they have a 1400 series box. 1400 series box started from this version of Pano, which is 11.0. Then 3000 series, it is end of sale. You can see end of sale right now. Still, you can purchase 3200 series, guys. Okay, but it is not supported the latest version of 11 series. Then 3400 series, 5200 series, 5410, 5420, 5430. You can run this version 10.2 onwards. But in PA 5440, you can run from here like 11.0. But in 1145, you have to run latest version, which is PanOS 11.1 only. We don't have any other option. Then they have a 7000 series where they have a 7500 firewalls. Then we can also go with the flexible firewall deployment with virtual CPU up to 30 core. And this flexible deployment is for generally for your virtualization environment. Okay. Or for your public cloud environment like GCP and all. Flexible vCPU firewalls, flexible vCPU up to 64 as well you can go. Then VM 50, 100, 200, 300, 500, 700 and 1000 V is also there for. Then these are the CN series devices. For small size or for medium and for large. But you can see still throughput is very, very less because you will run on top of your Kubernetes clusters. Okay. So here you can check the compatibility metrics. So you will get like if you will search for compatibility metrics, you will get all these details. Read through it before deploying like AWS reason if you want to deploy, check for AWS related information, right? Where you can deploy what, everything will be there. Okay. Now this is the place where you can able to see the data sheets. So here you can see we have a PF5410. Here you can see all the details of this box, like app ID throughput. It has a 52 Gbps of throughput. Means if you will configure this firewall with application ID feature in your environment, it can support up to 52 Gbps traffic per second. 52 GB per second. It's huge, right? If you will configure the content ID means you antivirus and all, then you can see it will reduce the throughput till 35. With IPsec VPN 20 Gbps. Connection per second, it will support around 2,70,000 sessions per second. You can check security policies. Somebody has asked what is the how many zones is supported, right? You will get here only. These many rules you can able to configure like 30,000 rule for security policies. Schedulers to 56. So always before doing any type of migration, right? Any type of deployment, always make sure you have documented all these details from your existing infra. Then you have to compare which box you have to choose. Maximum security zones. See, this firewall will support around 4,000 security zones. It's huge number. And guys, let me tell you one thing. Just remember, to be honest, see, they have mentioned here 52 Gbps traffic. So I'll recommend if you in your organization, if you have a traffic from 20 GB to 30 GB, then you will always go for this one. See, it's a document based stuff. Okay, we will not rely on this information 100%. Okay, always I will recommend when I will if I am designing any solution, I always recommend a box. See, let's suppose if my existing is 30, then I will recommend a box who is having around minimum of 40 Gbps he can support. So that's how I will do the calculation. Because I know, let's suppose suddenly you will have a CPS spike. What will happen in that case? Let's suppose you have a BPN, IPsec tunnel is there. And let's suppose all this tunnel is fluctuating. then your CPU may high, you will get a more traffic. So to avoid such type of stuffs, basically we have to design our solution. It's not like this is just a documentation. It can support up to, this is up to information. PA 50 to 20, 7000, 70 GPS, just check. Then 5430, 5440 and 5440. Even though like I know very big players, very big customers, they are using PA 5440. I have deployed just for with two of my customers. Then 3400 series, 3410, 20, 30 and 40. Then 1400, 1410. So this is the link. 1420, then 410, 415, because these are the new generation, and after that you will see the old generation here. Then they have a 7000 box, 70 80, 70 50, then 5450 is there, 5280 is there, right? So all these boxes are there. Just check into this link. You will have to go with product and product selection. You will able to see everything. 3200 series, in 800 series they have a 820, 850, 860. Oh, 860 they have removed. 820 and 850. In 32 they have 3220, 3250, 3260 and 3280 is also there. I think they have removed now. Even though 50 to 80 is also there, right? So all these series are there. You can always check their documentation. Whatever they used to remove, you will not found these devices here. Okay. So let me just put this link. Guys, I will also give you this particular text file today. Here I usually put all the links. Don't worry on that. Okay, guys, now let's have a break for 20 minutes. And after that, I will start SP3 because SP3 takes around 1 hour time minimum. Okay, guys, so now let me start the SP3 architecture in your Palo Alto firewall. So guys, let me tell you before starting that topic. See, this particular question regarding this SP3 architecture, you will get in most of the interviews. In most of the interviews, what they will ask you, can you just explain SP3 in Palo Alto? This is the first thing they will ask. Can you explain the SP3 in Palo Alto? They may also ask in this way, can you explain the parallel processing architecture of Palo Alto? Or they only ask like, can you explain the parallel architecture of Palo Alto? Or they may ask like, can you just explain the Palo Alto or PAN-OS architecture? So they will ask in this way, which means they are asking SP3. Okay. So let me tell you now. So Palo Alto network single pass architecture is known as a SP3 architecture. SP3 stand for single pass software. P means parallel processing hardware. This is the exact meaning of SP3 architecture. Means Palo Alto firewall have a single pass software and it is having the parallel processing hardware. So now, before going into single pass software, let me explain you the parallel processing hardware. So what they have done basically in your Palo Alto firewall, they have created its architecture into in two parts. Palo Alto divided its box into two parts. Control plane, which is also known as management plane, and has divided into data plane. They have a hardware level segregation, guys. What they have? They are having hardware level segregation. Just remember. They have a control plane which is known as management plane, and they have a data plane. Means at the hardware level also they have done that segregation. Control plane and management plane. Now, this particular management plane has a dedicated responsibilities. Management plane is having dedicated responsibilities. And your data plane having dedicated responsibilities. So in your Palo Alto firewall, your configuration management, your reporting and logging, your config management, generation of reports, generation of logs is handled by the management plane. Apart from these things, management plane is also responsible for managing the daemons or processes. Okay, it is also responsible for managing the daemons or processes in your Palo Alto firewall. Now, what do you mean by the daemons and processes? Let me just give you some glimpse of it. So if you will see this particular diagram in this image, we have a data plane and we have a management plane. So in your management plane, all these particular processes, they are running. These are the daemons. Your HA agent who will maintain your high availability in your Palo Alto firewall as a part of management plane. We will able to get the web access, web browser access, or when you will access the global protect, or when we will get the captive portal logging. It is handled by the app web 3. This is also running in your management plane. Your REST manager, which is a main daemon of your global protect VPN or remote access VPN, which is also part of management plane. Your crypto daemon, who will basically maintain the cryptographic stuff. Route D, your routing daemon is also part of management plane, who will basically responsible for computation of routings, managing the routing protocol like OSPF, BGP. Okay, your interface manager, your DSCP daemon, your authentication daemon. This is the daemon who will validate you have entered the correct username and password or not. Your IC manager responsible for IPsec VPN. Your key manager responsible for managing the keys. Dagger daemon, SMTPD, which will responsible for managing your SNMP service. SSL manager responsible for SSL related tasks. Log receiver daemon will responsible for log related tasks. User ID for managing the users. Management server responsible for managing the configuration, and there are lots of other tasks. Your dev server. These are the daemons which is a part of your management plane. And main daemon is the master daemon, master D, which is the father of all the daemons, and the system daemon, which is a mother of all the daemons. Means each and every demons, they will communicate with each other through system D, sysd only. So these demons management is also done by the management plane. And we do have a demons at data plane as well. Tunnel D, master D core, sysd agent, pen task, supervisor, pen DHA, EHMON, BRDs and MP relay and PANCOM. Okay, so this is how the daemon architecture in your Palo Alto firewall. Now, so your management plane responsible for four things majorly. Configuration management means whatever configuration we will do into the management plane. It will store the configuration into the management plane, right? Your generation of logs, generation of reports, and the daemons management is done by the management plane. Okay. And for management plane, Palo Alto have a dedicated hardware, dedicated multi-core CPU is there, or the dual core Intel processor is there in your management plane. So this is how the segregation they are having. Management plane and data plane is segregated, means at the hardware level they have separated. Now, your data plane is further divided into three another planes. Network processor, security processor, and content processor or signature match processor. Or you can also like that, like this is your network engine, this is your security engine, this is your signature match or pattern match engine. Means your data plane is further divided into three another components, or these are the dedicated three components we are having in your data plane. Your network plane will do the network related task, means it can able to process L3 and L2 and L4. Security processor is responsible for your security policies, net rules, all these stuffs. And content processor is responsible for your app ID task and content ID task. Means Palo Alto hardware is data plane is further divided into three another planes. Now, you will get one benefit because of that separation. Because you know each of these processor, they have dedicated CPU and dedicated RAM. Means they are not having any type of dependency on each other. At the RAM level, means at the hardware level, they are not dependent. Means all these particular processors, they can work independently. They are not dependent on each other. In other boxes, what used to happen in other vendor devices, they just have a one processor. That processor is shared by multiple processes. If one process is loaded with the traffic, then it may consume entire RAM and CPU. Another process will not able to functions properly. But because here we have a segregation at the hardware level, right? So these processor can able to process properly. And even though if we have a more traffic and network processor, then it will not impact on the security processor. Security processor works in his own phase. Same with the content match processor or pattern match processor. This is the benefit you will get with this type of architecture. Means all these three components, they can able to work parallelly. They are not dependent on each other. They can able to process the traffic parallelly. Okay, maybe let me just give you one example. Let's suppose we have received one packet at the data plane, like packet number one, packet number two, packet number three. Maybe packet number one processing happening here, two is happening here, and three packet processing happening here. Independently, they are just independent at the resource level, CPU and RAM level. So they can able to function separately. So that's the benefit we will be having with regards to this parallel processing hardware. Now, one more benefit you will get. Let's suppose somebody has launched the DDoS attack in your data plane, in your data ports like Ethernet 1 by 1. Then your management plane is safe. We can basically log into your firewall through management plane, and we can write the necessary, or we can take the necessary actions to prevent from this DDoS attack. If your management plane under the DOS attack, then our data plane is safe. Your users traffic will not impact. As I have mentioned, we are having demons, right? Let's suppose your data plane component like your network processor or security processor or content processor is not working fine, and we need to reboot the box to fix that problem. Then you don't need to reboot the entire firewall. You can just reboot that particular data plane only. Just reboot the data plane only. You don't need to reboot the entire stuff. With regards to management plane, let's suppose there is a process called auth. Your authentication is not happening properly. There is some type of bug is hitting on your auth process. Then you can restart your authentication daemon. You don't need to restart the entire box. That process is still itself you can able to restart. That's it. So that these are the benefit you will get with regards to this parallel processing hardware. Now let me go in more deep on the same. Now, So guys, if you will see these three things, these are the three component of data plane. These are the three component of data plane. Okay. Where in these components, this is known as network processor. This is a FPGA or ASIC. It is also act as a session offloader. This particular processor name is network processor and the chip name is FE100. This chip you will see in the new generation boxes. In old generation boxes like first generation boxes, that chip name was Liger or Tiger chip. Like either they have in low end boxes you have a Liger chip, in high end boxes we have a Tiger chip. This is the name of exactly the hardware component or ASIC in your Palo Alto firewall. And that particular network processor, it can able to process the packet using L2, L3 and L4 information. And it is a session offloader. Session offloader means this processor only responsible for processing the packet which is offloaded by the Octeon chip, because this is a main data plane component, DPCPU or the security processor. This is a security processor. And according to the life of a packet or according to the packet flow, like this ingress stage, your flow lookup, your slow path, fast path, and forwarding, it is done by the security processor only. Always this particular processor will do. This network processor will handle the packet if some packet is offloaded by the Octeon chip or the data plane CPU. And guys, I'm talking about the data path of Palo Alto 5200 series box. In Palo Alto 5200 series box, here we are having three security processor, DP0, DP1 and DP2. And guys, your actual parallel processing hardware is implemented in the high-end boxes. In low-end boxes, you just have a single processor, single multi-core processor. But in 5200 series or 7000 series box, we have a multi-core processors here, means multiple CPUs are there at the data plane. These are the Octeon chip. So your actual SP3 is implemented in the high-end boxes only, guys. Just remember. In low-end boxes like PF400 series, you will not have network processor. You are not having Jaguar chip. No, only one Octeon chip will be there. And that chip will do everything, all the task. In 800 box also, only Octeon chip will be there. No network processor, no signature match processor. Just remember that. But in high-end boxes like Palo Alto 5200 series, 7000 series, we have a like here I have a two signature match processor. We have a two signature match processor in 5200 series box. Okay. So means now we have a interfaces. All these interfaces, they have a connectivity with the chip called Qumran chip. Then this Qumran chip will have a connectivity with the FE100 chip via the joy links. These are the high speed fiber links. These are the high speed fiber links named as joy links. Okay. Then we have a Octeon chip, which is your DPCPU1, DPCPU D0, 1 and 2. Then we have a signature match processor where we have a chip which is C100. In low end, in your old generation boxes, that chip name was Jaguar chip or like Ocelot or Jaguar. These are the two chip was there. Jaguar chip or either the Ocelot chip. Now, This signature match processor is responsible for app ID task and content ID task. And guys, there are two main algorithms which are running, or the some type of, we need some type of program or code, right? Who can basically do this app identification and content identification, right? So we have a one program called PenDHA. One minute. So we have a main two program or algorithm which is AHO and DFA. Nowadays DFA is basically replaced by the PScan algorithm. So these are the two algorithms which are running on your Jaguar chip, and they will do the app ID and content ID related task. Let's take an example. Let's take example of 800 series box. In 800 series box, we are not having dedicated hardware component for signature matching. Then these two algorithms, they will run on the Octium chip, and they will do app ID and content ID related tasks. Just remember. Network processor also you will not found in all the boxes. Only few boxes only have a network processor. Means you can check like which box support the session offloading. If session offloading is supported, which means that box have the network processor. Okay, so that's how the hardware component is there in your Palo Alto firewall. And your actual parallel processing is implemented in these high-end boxes only. Because let's take an example, we are receiving some packets here. Let's say we have received 1, 2, and 3 packet. Maybe your first packet processing is happening here. Second is processed by the DPCPU1. Third packet may be processed by the DPCPU2. Maybe first packet for layer 7 it will send to here, and third one may be here. Means you're all the packet getting processing parallelly. And here guys, we are having multi-core CPU. Multiple cores are there for CPU. Means it can process multiple packets at the same time. Multiple, like we have a 128 core, 64 core as well at that chip level. Okay. Now, one more thing I wanted to tell you guys. This was the old architecture basically. In old architecture, what you used to have basically, if you this is just for the information purpose, guys. See, in old architecture, we used to have a copper ports and fiber ports or SFP ports. So your copper port used to have a connectivity with one chip called Marvel chip, and copper ports used to have a fiber port used to have a connectivity with the chip called Petra chip. And this particular chip has a connectivity with either the Liger chip or either the Tiger chip, which is a network processor. It's a FPGA through joy links. And after that, we have a data plane CPU where we have a Octeon chip, security processor. Then we have a Jaguar chip, which is your signature match processor. This is also a FPGA. Okay. Now, as I mentioned, according to the packet flow, like ingress, stage flow, lookup, slow path, fast path, app ID, content ID, and forwarding. So where your app ID and content ID, these task is always done by the signature match processor. Your ingress, stage, flow, lookup, slow path, fast path, and forwarding is done by the security processor or Octeon chip or DP CPU. Your network processor come in a picture if some session is offloaded by the Octeon chip or the network or the security processor to network processor. Now your ingress, flow lookup, fast path, and forwarding is done by the network processor. Only the offloaded sessions. This is at the data plane level, guys. That's how Palo Alto architecture at the data plane. Just remember. Now let me just go here. Let me just explain you. If you will see this particular diagram, Like you can, like both are similar only. So you know, this is the diagram like that. We have a management plane, which is your control plane. Then we have a data plane where we have a signature match processor, security processor, and network processor. And your signature match processor have a dedicated RAM and CPU, right? It's a FPGA, so they already have a CPU chips over there, and they have a direct connectivity with the data interfaces. So control plane or management plane provides the configuration management, logging, and reporting functions on a separate processor. They have a dedicated RAM and dedicated hard drive. Means your management plane have a dedicated CPU, dedicated RAM, dedicated SSD, management port, and dedicated HA1 port. HA1 port is also a part of management plane only. Then we have signature matching. It will do your stream-based signature matching, uniform signature match, including the vulnerability exploit, virus, spyware, command and control, and the data filtering for social security numbers and credit cards. All these layer 7 tasks or content ID and app ID related tasks done by this engine. Security processor, high density parallel processing for flexible hardware, acceleration for the complex function. Means this particular processor have a dedicated RAM and CPU, and it is responsible for your packet processing according to the life of a packet or the according to the packet flow. Now, just remember one thing, this security processor, it is also having a three more small chips. We have a dedicated chip for IPsec functionalities, dedicated hardware chip for your SSL proxy related task, and we have a dedicated chip for the compression and decompression. Along with the Octeon chip, we have a dedicated hardware, small hardware chips for all these three tasks. Then we have a network processor. Front-end network processing, hardware acceleration per packet, route lookup, MAC lookup, and net. So it can able to do all these tasks. Even though I have written all these things here as well, packet routing, all these tasks, networking can do, security processor can do. Okay. Here also the same thing. Now, I wanted to explain you this architecture. This is the architecture of Palo Alto 3000 series boxes. In Palo Alto 3000 boxes, you can see we have a dedicated management plane or control plane where we have a Intel CPU. So it's a dual core CPU. We have a two CPUs. We have a dedicated, we have a two RAM slot, and we have a two hard drive slots. Then we have a network processor where we will be having EZ chip. EZ chip is also known as Liger chip or Tiger chip. Then we have a multi-core security processor, which is have a Octeon chip, and it have a multi-core. See, 16 core of CPU, dedicated RAM, and dedicated SSL chip for SSL related task, dedicated IPsec chip for IPsec related task, and dedicated chip for decompression. It's a part of data plane. Then we have a signature match processor where we have a RAM, because mostly RAM required at, and we have a this particular hardware component name is Jaguar chip. This is the PA 3000 series box. Then we have a Palo Alto 5000 series box. You can see this is the architecture of 5000 series box. Here, what they have extra? And instead of one CPU at data plane, they have a three CPU. This is DP0, this is DP1, this is DP2. They have a two Jaguar chip, chip number one and chip number two. And they have a dedicated management plane where they have a 4 core of CPU, RAM, and SSD for management related task. They have a dedicated switch fabric where they have a Petra chip. This chip has a connectivity with the network processor where we have a Tiger chip. We have which has a connectivity with these particular data plane CPUs, where we have a Octeon chip. Then we have a signature match processor engine, where we have a Jaguar chip. So this is the architecture of Palo Alto 5000 series box. Now, in this Palo Alto 5000 series box, basically what you have to remember, see your actual SP3, I can say your parallel processing is applied where you have a multiple Octeon chip, because we have a three dedicated processors and who is basically processing the packet independently. That is the parallel processing architecture of your Palo Alto firewall. It's the same thing. I don't want to cover again and again. Multipass architecture, I will come later. Now, I'll come back to this diagram again. So, in this diagram, if you will see, we have a data plane further divided into three another planes, or data plane have a three another components, right? Network processor, security processor, and pattern match processor, signature match processor. And these particular processor, they will handle the packet independently in parallel way. So guys, I hope you have understood the parallel processing hardware architecture of Palo Alto. I got one question like control and data plane are separated in all PA models, including lower end models. See, in lower end models, we just have a one single chip. Okay. Now, so all models will not have a same type of architecture. There is a some here and there. And I do have one more thing. Let me just go here. So this was the block diagram, and this is also known as data path. And if you will see this particular, these are the official Palo Alto is only. See, if you will see here in this, physical interfaces have a connectivity with the network via network processor, then security processor, then pattern match processor. Okay. And these are the details of these chips little bit. Sometime you will see here and there. Like this network processor is also act as a session offloader. EZ chip somewhere you will see it's FPGA, it's a ASIC, and mostly it will provide the session offloading. Security processor with some multi-core CPU, it is also known as data plane CPU. We have a KVM processor or the Octeon processor. Okay, let me go down. This is again a part of packet flow only. So I will cover this in packet flow now. Okay, now see guys, this is the parallel processing hardware of your Palo Alto 5. Now let me just explain you the single pass software architecture, how the single pass software looks like. So in single pass software, basically what used to happen generally, see your actual single pass software, this concept of single pass software, now we are discussing at the software level. We have seen the hardware level. Now at the software level, what used to happen basically, see this at the software level, it is applicable at your content engine. During the content ID, your single pass software comes in a picture. What used to happen basically, let's take an example. We have a architecture like this. So generally, as I have mentioned, when your firewall will do the content ID related task, which includes the your antivirus protection, your anti-spyware protection, your vulnerability protection, okay, your URL filtering, file protection, data protection, your wildfire protection, right? All these type of protection is done by the Jaguar chip, right? Or C100, right? In new end boxes. So this Jaguar chip, and you have seen in Jaguar chip majority of the things you have seen with regards to the RAM. So what used to happen basically when data, see if your data is marked for the content identification, if your layer 7 security profiles is configured, then this packet will go. So only the layer 7 information from that packet will pass to the Jaguar chip, and it will store that particular layer 7 information into these memory locations. These are the memory location where it has stored all that information. Okay. In these memory location, it has stored all that layer 7 information, because we used to get a chunks of information in the packets, right? Now what it will do, this content engine will do, see we have a antivirus related signatures are running here, anti spyware related signatures are running here, vulnerability related signatures are here, your URL filtering related database is here, your file blocking data filtering wildfire signatures, your app identification related signatures are here. What they will do, all these signatures, what they will do, they will load that packet once. All these particular signatures, they got checked once basically in just in a one go. Match happens against these exploit just in one go, and they will basically report the output. Means your packet is stored just once in the memory and gets processed. Means it is doing the stream based signature matching, and your packet sending out, or whatever the results is there, that particular your Jaguar chip will inform to your Octeon chip. If there is any type of X threats are there, then it will send that message. There is a threat detected, and your Octeon chip will discard that packet. It will change the state of your session as well as a discard one. So what happening here, we are storing that particular information once in a Jaguar chip, and we are processing all these particular code. They are processing this information just in one go. That is known as your single pass software architecture. Now I know maybe you will not get it 100% here. Now let me explain you the multi-pass architecture. In multi-pass architecture, what used to happen, if you will see this particular diagram, we have a Cisco ASA firewall. This is your Cisco IPS. This is your Cisco proxy, which is like WSA. Then we have a for antivirus protection and DLP. Let's say we have a, even though for DLP for URL filtering, we need a WSA, right? For DLP, we need a AMP solution, right? So what used to happen when, let's suppose there is a one user, that user is trying to access these servers. So he will send his traffic. First, his traffic processed by the Cisco ASA, means this component. Your ASA receive the packet, it will do the decoding of the packet, parsing of each headers, right? Then it will match against the security policy, net rules and all, right? Means it is doing the I protocol and port based analysis. and after it will pass this packet to the IPS. Now this IPS will do the signature matching, IPS decoders, port based identification, right? And it will do the parsing also again for the same packet. Parsing, port and protocol based protection, then IPS decoders, IPS signatures, and IPS policies. Then this IPS will basically forward this packet, let's suppose, to URL filtering. Then in URL filtering, again your parsing will happen. Again, your port based analysis will happen, then HTTP decoding and the URL filtering policy. Then if you have a DLP engine, then again for DLP, it will go like that, or for proxy. So if you will see here, each time these task is repeating or not. Port and protocol based identification is repeated multiple times. And when your packet is handed over to the IPS, it will basically stored inside the IPS engine somewhere on the RAM, right? When this packet go for the URL filtering, then it will be stored somewhere into the URL filtering. Means how it is happening, how the processing is happening. Means each and every packet they are parsing from starting, right? They are parsing that packet from starting, and after that one component is doing. Means they are not processing simultaneously. It's not happening on the parallel way. Just in one go, it is not happening. Your multiple, this packet is having going through all these tasks repeatedly. And if you will go through these tasks repeatedly, then it will add some delay, right? It will add some processing delay. So that's your multi-pass architecture. In multi-pass architecture, what used to happen? Your packet usually store into the RAM, then IPS function will applied. And after that, your packet handed over to the URL filtering. Then in URL filtering engine, it will store. Then your URL filtering processing will happen. But in Palo Alto, how it is happening? All these tasks is happening just in one go. They were stored on the Jaguar chip, and all these particular signature matching happen just in one go. Nothing is repeating. We are not doing protocol and port based analysis every time. We are not doing the parsing at layer 2 and layer 3 every time. Nothing like that. Right. So that's how the single pass software architecture works in your Palo Alto firewall. Now, you may ask why other vendors they have not implemented the same type of software level architecture. Why they have not implemented this type of architecture? What is the reason behind that, right? There must be some reason. So guys, if you know Cisco FTD, I will take the example of Cisco. If you know the Cisco example of Cisco FTD, what they have done? Do you think this FTD source code they have basically created from scratch? No. What they have done? They have take out the ASA code, which is known as Lena engine on ASA. They have take out the IPS code, which is known as snot engine or source fire, you can say. For URL filtering, they have taken out the WS engine, WSA code, and for malware related protection, they have basically take out the AMP code, advanced malware protection. And all these four code they have put together and they have make FTD box. Okay, they have basically not programmed everything from scratch. So they have a Lena program which is running, which will basically do the processing using this. Then IPS they are running as a separate. So IPS will functions like this, means parsing Every program will do the parsing again and again. Means they have basically done, they have created this FTD with the help of acquisition of multiple their existing product. That's the problem we are having with FTD. Even though your 40 gate is also UTM based box, right? Means if you will basically enable any extra feature at the UTM level, means that feature code run separately. That feature code or source code which or program will run separately. Means separate processing it will do at the packet level. Okay. So you got the point here. This multipass architecture at the software level, guys. Write yes in the chat if you will got it. If you have not understand, then just type no. I will repeat. I hope most of you got that particular point. Let me repeat one more time. But so in multipass architecture, what used to happen? Now let me just draw like that. Okay. Draw a proper diagram so you will understand. We have a Lina engine. I am going with the Cisco, guys. This is your ASA firewall. On top of Lina, they are running Snort. On top of Snort, they are running WSA. Then they are running AMP. So what used to happen? Your packet, when it will receive by the Lina engine. So it will do the processing at layer 2, layer 3. It will do the port and protocol based analysis, and it will basically apply the security policies. Okay. Now when Lina processing is completed, now your packet is handed over to the Snort engine, which is IPS. Now your IPS will do the layer 2 and layer 3 processing, port and protocol based processing, IPS decoding, IPS signatures, and IPS policy. Then your packet will hand over to the URL filtering engine, where L2, L3 again, port based protocol again, ST decoding and URL filtering policy. Then it will go for M, advanced malware protection, where again it is basically matching all these. You can think here AMP signatures, not AB, it's just the AMP signatures. That is the multipass architecture. Because see, all these programs, they are running separately, right? And if they want to process something, until you will provide the proper information, they will not able to process it, right? So here processing happening serially, one after that another, right? But in Palo Alto, everything happening just together in one go. So that's the multi-pass architecture, guys. In Palo Alto have a single pass architecture. I do have a one more thing here, like this is the one, right? They will store that data one time, and they will all these particular signatures just checked once and done. Job is done. Layer 7 is complete. This is your single pass software architecture of your Palo Alto firewall. And it is applicable for Jaguar chip only for content ID. Just remember, guys. It is applicable only for content ID, not even though not for application identity, app ID. No, only for content ID. Okay. So Palo Alto architecture is the SP3 architecture, guys. Single pass software and parallel processing hardware. Okay, this is what I wanted to cover with regards to your today's class. In next class, we will see these two topics. I have seen one question like, apart from Palo Alto, any other vendor support single pass circuit? I have not seen any other vendor supporting that feature. According to me, nobody supported. Only Palo Alto is the first firewall who has a SP3 type of architecture.